Back to our videos for the practice final exam. Number 9 is where we're starting. Find the domain of the function f of x equals x plus 4 over x squared minus 7x plus 10. Now this function is a rational function. It's a fraction made of polynomials. Domain is the set of x's you can plug into a function and get an answer out. So what we do to find our domain is find our trouble spots. So what do we have trouble with in a fraction? Well, we have trouble if the denominator is 0. So we want to figure out what makes the bottom 0. It's a quadratic that we can solve by factoring, and it will factor as x minus 2 times x minus 5. We can multiply it back out to check it, but that's right. Now we set each factor equal to 0, and we solve and get x equals 2 or x equals 5. Now those are the numbers that cause trouble with the function. They will give us 0 in the bottom. So we have a number line with all of our numbers on it. These are the ones that we have to throw away. They are the ones that we cannot touch. But we have lots of other x's in these other regions, and those are the ones that make up the domain. So reading that number line from left to right, our domain is made up of all the x's to the left of 2, so negative infinity to negative 2, and it's made up of all the x's between 2 and 5, so union 2 to 5, and the domain is made up of all the x's to the right of 5, so we represent that with 5 to infinity. Now we have to use parentheses on these. 2 and 5 are the numbers we cannot touch. Parentheses tell us we can get close, but never touch them. Number 10, find the domain for f of x equals square root of 6x plus 18. Now this time we have a radical function. When we have a radical function, if we have an even index, then whatever sits under that radical cannot be negative. Well, if it can't be negative, that means it has to be 0 or greater. So greater than or equal to 0. If we have an odd index, then what sits under that radical can be anything. It can be positive or negative or 0. In this case, we have an even index. It's an understood 2. So we're going to take that expression that sits under the radical and set it greater than or equal to 0 and solve. So subtract 18 on both sides and then divide both sides by 6, and we get x is greater than or equal to negative 3. Now that's our domain, but we want to write that answer in interval notation. So if you need the number line to help you get it, draw your number line. There's our number negative 3. X's have to be greater than. That tells us to shade to the right, or equal to, and that tells us to use a bracket. The bracket says you can touch the number, okay? So in interval notation, we're starting our x's at the negative 3, including the negative 3, and everything shaded to the right we call positive infinity. (11) and 12, we are given two functions and we want to do certain things with them. So in 11, find f minus g of x. Well, by definition, f minus g of x is equal to f of x minus g of x. So we're just going to put our functions in and work with them. F of x is 6x plus 7 minus g of x, which is 3x minus 8. Now, that whole function gets subtracted. So these parentheses after that minus sign are important. It's the whole function f of x minus the whole function g of x. And I don't know why it put that red mark on the x. It's just doing funny things. All right. Well, why are those parentheses important? That tells us we have to distribute this negative. That whole function is getting subtracted. So just remove parentheses from the first part. Distributing the negative will give us a minus 3x plus 8. And now we combine like terms. So 6x minus 3x minus 3x gives us 3x, and then combine the constants. So a positive 7 plus 8 will give us a plus 15. Now, had this been a plus sign instead of a minus in what it tells us to do, then you would just be adding everything. You wouldn't have to distribute a negative. If it had been f times g, then you would write down f of x times g of x and use FOIL to work through it. Okay, so those are just operations on functions. Number 12, find the composition. That f circle g, that little circle does not mean multiplication, it means composition. We rewrite this notation as f of g of x, which means we want to find f of 7x squared minus 4. Now think about it. If this told us to find f of 2, we would simply go to the function f and plug 2 in for the x. Well, that 7x squared minus 4, it's like that too. It just looks different. But we're going to go to the function f and plug that in. So we will get 5 times 7x squared minus 4 plus 6. Just like we plugged in that 2 over there to the left, we're plugging in our g, which is 7x squared minus 4. Now what we need to do is distribute the 5, and we get 35x squared minus 20 plus 6, and then combine like terms, and we get 35x squared minus 14. (13) and 14, inverse functions. Now, you've got steps in your notes of how to do these. For inverse functions, I'll just remind you quickly. The first thing we do is call f of x y. So we just rename it. Then we swap out our x's and y's. We just trade places. Then we solve for our new y. And then we call y f inverse of x. So those are the steps to go through. So in number 13, call f of x y. Swap out your variables. So everywhere there's a y, put an x. Everywhere there's an x, put a y. Now solve for y. So let's add 4 on both sides. And then let's divide both sides by 8. And then we call y f inverse. Now, we can leave the answer written this way. It's multiple choice, and honestly, I just don't remember how it's going to look. But the option is this. We could break it into pieces, and then that second piece would simplify. So you either would see this form or that broken apart form. Now in number 14, we go through the same steps. We call y f of x. We swap out the variables. So where there's an x, put a y. Where there's a y, put an x. Now we solve for y. So add 9 on both sides. And we get y cubed equals x plus 9. But we don't want y cubed, we want y. Well, how do we get rid of a y cubed? How do we get rid of that third power? Well, if we raise it to the 1/3, remember raising a power to a power says multiply them. So 3 times 1/3 is 1, and we just get y. But if we do that on the right, we have to do it on the left. So now we get y equals x plus 9 to the 1/3, and that is our f inverse. Now, to the 1/3 power means the same thing as the cube root. So you might see that written either way. And that's the end of this segment. We will pick back up with number 15.